Thank you, John, and good morning, everyone. And also thank Craig Fuller for the nice shout out this morning. I'm Ken Craig, the Vice President of Special Projects at McLeod. A few years ago, we developed an extension to our TMS architecture called FlowLogix, which allows our customers to perform business process automation using visual tools. FlowLogix enables business process owners the ability to design and create smart workflows and process automation. We believe that business process automation will be crucial to the effective use of blockchain by transportation providers. Today we will introduce you to FlowLogix for smart contracts. This will allow the design, creation, and validation of smart contracts without using programmers. Bill Deason, one of our senior architects at McLeod, will now demonstrate an oversimplified example of a smart contract between a shipper and a carrier.
Thanks, Kim. What we're going to demonstrate today is how to create a blockchain application using FlowLogix. Let me go over our example use case first before we get into that. In transportation, it's very common to have a rate negotiated on a volume per time period basis, something like loads per week. And even though those are very common types of agreements, they're not necessarily the easiest to manage. So we want to create a smart contract on a blockchain to help with that. As Ken said, this is going to be a simple solution, but it'll be a useful one to talk about. This will be a smart contract between a carrier and a shipper, where a carrier has agreed to do a certain number of loads per week for a shipper at a certain rate in a certain lane. The carrier is going to create a smart contract instance on the blockchain, and then the shipper is going to access that smart contract to get tokens, 1 token per load. And then what the shipper can do is they can pass that token to the carrier with their load tender, and the shipper and the carrier can be in agreement on the rates. They can both be ensured that the rate is correct. What we're looking at on the screen here is called FlowLogix Designer. In FlowLogix Designer, we have a contract management project, which is what we're calling our smart contract. Here is a function that the carrier would use to create the instance on the blockchain. And the create token is what the shipper is going to call to get tokens. I'll walk through this real quickly. So we come into this create token function, again being called by the shipper, and we first want to make sure that we're being requested by the right shipper. We don't want this to respond to anybody that it's not meant for. If not, we just don't do anything. If we've already handed out our tokens for this contract for the period, then we're going to send back a special token to the carrier which says you need to call and get a new rate for this load. You don't have any more tokens on this contract right now. Otherwise, we create a token, which right now is just a hash of some of the data related to the rate, but in the future would probably be a blockchain address of its own. Then we increment the number of tokens used, and we're done. One of the coolest things about FlowLogix is that it's executable. So we can step through the logic. Sorry, went to the wrong function. I have these 2 test functions that I'm going to step through, and we'll see why. This one is set up to just work like a normal carrier interaction where they're going to go and get a token from the smart contract. And we'll see that it flows through like we expect it to. And then I have another test which is intentionally set up to be out of tokens for the week, because you'd want to test that for sure. And I'll step through there, and we're done. Okay, now once a user has created their logic within FlowLogix and they're happy with it, they've debugged it, we can move on to smart contracts in blockchain. I have an instance of Quorum, which is an Ethereum-based blockchain running on my laptop here today, although we intend to be completely agnostic when it comes to which blockchain someone might want to run on. And then within LoadMaster, we have created a screen called our blockchain contract screen. What we can do with this is we can pull the logic from FlowLogix, and we see that it's created an Ethereum Solidity implementation of that logic. Here's our create token function. And after importing it, we can compile it. And that's created our interface and our binary representation of the code. And then we can construct an instance, and we can get the address of that instance. We can also, even from this screen, we can invoke functions on that smart contract for further debugging or whatever. But just for the purpose of the demo, I've created a couple of sort of user-friendly screens that a carrier or shipper might use. So maybe a carrier is going to select a particular shipper and a particular lane, and they will say that this contract expires in 7 days. It'd be a per mile. We'll say it's $1.80, and there'll be 3 loads per week, just to make this easy. And we tell it to create agreement, and it goes over to our blockchain and is creating those instances. The reason I printed out the address of the instance is that this is the number you'd have to get to the shipper. This is how the shipper would reference the smart contract on the blockchain. And then we have another little screen that might be something like a shipper would use. So they would also pick the same lane, and they would say ship date, maybe it's tomorrow, and they just get tokens. There's 1 and 2. And the interesting thing, here is once they hit 4, we're going to send back just a token of all zeros, indicating that they don't have any more tokens remaining for the week. So at McLeod Software, we're completely dedicated to making sure our customers have great, highly automated business processes using FlowLogix, and that includes best integration to industry standard blockchains. Thank you.